This experiment will study the data from the two types of heat conduction configuration. An example is linear and radial module. The heat conduction study, the bench consists of two electrically heated modules that mounted on a bench support frame.
One module contains a cylindrical metal bar arrangement for a variety of linear conduction experiments, while the other consists of a disc for radial conduction experiment. Both test modules are equipped with an array of temperature sensors.
Cooling water to be supplied from a standard laboratory tap is fed to one side of the test piece in order to maintain a steady temperature gradient. Computer will display the direct reading of the temperature sensors and power input to the heater for ease of monitoring and data acquisition.
I'm free. Got an opportunity to make the world work for me, and I'm gonna take it.
Connect one of the water tubes to the water supply and the other to drain. Connect the heater supply leg for the radial conduction module into the power supply socket on the control panel. Connect the 6 sensor leads to the radial module with the TT1 connected to the innermost plug on the radial. Rotate the heater power control knob control panel to the fully anti-clockwise position. Set the power to the auto position.
Set the heater power to 20 watts and allow sufficient time for a steady state condition. Then, record the temperature at all 6 sensor points and the input power reading on the wattmeter. Next, this procedure should be repeated for other input power up to the maximum permitted when T is equal to 100. After each change, sufficient time must be allowed to achieve steady state condition.
Now, let us proceed with the second experiment, that is to investigate the influence of thermal insulation upon conduction of heat between adjacent metals. The first step is to make sure that the power is in the off position. Next, insert brass conductor section into linear module and clamp together. Third, place an insulation material such as paper, cork or blank between specimen section and core section. Then, connect one of the water tubes to the water supply and the other to the drain. Connect the heater supply lead for the line conduction module into the power supply socket on the control panel. After that, connect the 6 sensor leads to the plugs on top of the linear conduction module. Then, rotate the heater power control knob to the fully anti-clockwise position. Set the power to the auto position. Then, set heater power to 20 watts and allow sufficient time for steady state condition. Lastly, Record the temperature at all 6 sensor points and the input power reading on the watt meter.
In conclusion, the length, power, the inner radius, the outer radius, inlet temperature and the outlet temperature are essential in determining the thermal conductivity of the insulation material. The thermal conductivity for experiment 1 were calculated using a specific volume. The thermal conductivity was acquired to show how good of an insulator the insulation material is. By the end of the experiment, the objectives were achieved, which are to examine the temperature profile and to determine the rate of heat transfer resulting from radial heat conduction through the wall of a cylinder, and also to investigate the influence of thermal insulation upon the conduction of heat between adjacent metals. Overall, this experiment has been a success as the results obtained will support much with the theory. That concludes our video presentation on conduction. But before we end our presentation, we would like to apologize if we have done anything that might have offended the audience, and we would like to dedicate our deepest appreciation to our subject's lecturer, Madam Ami, also not forgetting our friends who have aided us in achieving the success of the experiment. Thank you and Assalamualaikum.
Hi, I'm Nurul Akila. Now we'll proceed to the second part of our video, which is the application of conduction in our daily life. So this is the first example. Check it out.
Number 1. Number 2.
We're going on a trip in our favorite rocket ship, zooming through the sky. Little Einstein, climb aboard, get ready to explore. There's so much to find. Little Einstein, we're going on a mission. Start the countdown. 5, 4, 3, 2, 1. Everyone to rocket, rev it up now.
Number 3.
A shirt is placed on an ironing board to be ironed. Heat from the iron is conducted to the shirt, making it easy to iron out all those unsightly wrinkles and make the shirt look sharp.
Number 3.
When a young boy walks outside barefoot on a hot summer day, the heat from the hot floor is conducted to his feet and his feet become hot. This is because heat is conducted from the hot floor to the boy.